To be working, and we are good to go. Okay, today is day 3 of Solidworks, and as a result we're going to be talking about our third of the big 3 features we're going to be using to create our parts. We've talked about the extruded boss slash base, we've talked about the revolved boss slash base. Today we're going to be talking about the swept boss slash base. I will warn you though that we went extra slow on day 1 to try to make sure that everyone was on the same page, because if you get lost early on, then catching up is difficult. And then we accelerated the pacing of the material a little bit for week 2. I'm going to be accelerating a bit more. I will remind you that the goal of lecture is not for you to follow along with everything that I'm doing. The goal is for you to be familiar with how you might use features, and you should be thinking more about why I'm clicking the things that I'm clicking and why I'm doing the things that I'm doing, and less focused on trying to recreate everything that I'm doing on your screen. Because inevitably you will probably fall behind at some point, and then you will be frustrated about falling behind and not paying attention to what we're doing, and then it's downhill from there. Understood? Okay, so the extruded boss slash base, the revolved boss slash base, all used one sketch. You created a sketch, and then you created material by manipulating that sketch. The swept boss and the swept cut used 2 sketches. You create a sketch for the shape that you want to sweep through space, and you create a second sketch for the path you want to follow when you create matter or remove material. So, as an example, let's try a shape like this. This handle would be something that you could model with an extruded base and with a revolved base. I mean, you could create 1 extrusion of a cylinder, and then 2 more extrusions of cylinders, and then you can create a revolved base for those corners, but we can make it one feature by using the sweep feature. We can create one sketch that represents the shape to sweep through space. In this case, that would be a circle. And then we create another sketch that represents the path to follow that sketch with. So one of our sketches will be a circle. The other sketch will be like a skeleton of this handle. It'll be a line, it'll be an arc, it'll be a line, an arc, and a line. Does that make sense? When you're creating sweeps, the important things to keep in mind are, 1, Solidworks gets a little bit finicky if your sweep intersects itself. So in this case, you couldn't use a sweep if that radius of the corner was smaller than the radius of the handle itself. I mean, if you can imagine trying to figure out how to manipulate that sketch so that it swept through itself as it was going around a corner. If it was too tight a corner, it would overlap itself, and Solidworks just bails at that point. 2, you have to keep in mind that your sketch to sweep through space has to be positioned relative to the sketch to follow. So in this case, I want to position my sketch to sweep through space such that it is intersecting my sketch to follow on one of the endpoints. Does that make sense? So I'm going to create one sketch on the front plane here, because I want to match these views, and I'll create a second sketch on the plane corresponding to wherever the endpoints of my handle are. So if I were to, for example, create the handle like this, so that the endpoints were below the origin, I don't have a plane corresponding to these endpoints. So the closest I could get would be to draw a sketch on the top plane that awkwardly intersected like half of this leg, and then we'd have to create 2 extrusions, one going one way, one going the other way. This is the sort of situation where keeping in mind where your cardinal planes are, i.e. positioning your origin, is especially helpful. Instead of creating the endpoints below my origin, if I actually align them with my origin, now when I draw on the top plane, I can create something that starts at the endpoint of this sketch. So as I sweep through space and follow it, it only has to go one direction. Are you following that logic? Okay. So now I've drawn 3 lines. I could add arcs to them. I could also create those curves in the corners by adding fillets. So this tool here below the ellipse is called a fillet. The fillet creates a curve from an intersection of 2 lines. So if I were to click, for example, this line on the left, this line on the top, it says, hey, FYI, this is going to break any of your dimensions that are regarding the length of that line and relative positioning of that line to other things. Earlier, I had created a relationship between the midpoint of the line and the origin. It's just warning me, hey, You may want to keep in mind how this is going to affect the length of that line. And I say, I got it, SolidWorks, I know. We're good. And then it creates a little preview of what that fillet is going to look like. I could do the same thing on the other corner and create another arc. It says, hey, just be aware of how the length of your horizontal line is affected. I say, I know, it's fine. Now, what radius would you like to use for this fillet? So we have to create the center of this handle. So we don't want it to be 0.075 meters, We don't want it to be 0.125 because both of those would be on the outside edge of the handle. One on the inside of the curve, one on the outside of the curve. We want the center. So we want a radius that's halfway between 0.075 and 0.125, which would be 0.1. If we didn't want to do that math to average the two numbers, we could have SolidWorks do the math for us. But whatever the case, 0.1 meters, 0.1 meters. I'm typing in 0.1, typing in an M because multiplying by 1,000 is too much to do past about 3 o'clock on a Tuesday. Now I can click the green check mark and it repositions my sketch to create the scale that would allow for this radius. I haven't scaled anything else, and remember, the first dimension that you add to a sketch scales the rest of the sketch. So now we have a radius with a 10 millimeter dimension. If I wanted to change that again, I can go 0.1 meters. Hit OK. Why are you bailing, SolidWorks? It seems to think that it's done with its job when I add that dimension. But it's not. So I typed in 0.1 meters. That's 100 millimeters most Tuesdays. And it doesn't break. Hooray. Now, what dimension would you like to add next? We've got like 2 left. Well, I said one dimension, man. You named the 2. We have to start somewhere.
We'll start there.
Okay. The width here could be referring to the distance between these vertical legs of the handle. What would you like the length of that distance to be? 0.5 meters. Which view did you get that dimension from? Well done. 0.5. Again, we are dimensioning between... Nope. I guess we're really not getting a handle on this sketch. So remember that we are dimensioning the distance between the legs, so we want the distance to be the skeleton at the center of the cylinder, not the outside edges, not the inside edges. Conveniently, on the top view, that distance is specified from the center, which is what we want. Okay, we have 1 dimension left. Please help me.
We can do the height.
I like it. Let's do the height. So we click on one of these endpoints. We click on the top. That allows us to dimension the height. What length would you like that distance to be? 0.25 meters. Okay, now let's address the fact that neither of these are right. Why aren't they right?
Because they're dimensioned to the center of the circle, which would be the center of your arc.
Yes, but in this case, the sweep is going to be following the center of this sketch. So as I sweep around, I actually do want 0.5, and I actually do want 0.25. I could also, when I create my second sketch, which you'll see in a second, I could also position that sketch to be on the outside or inside of this secondary sketch, but it happens to be more convenient in this case to create our center line as one of the profiles to follow. Other questions? Okay, are those dimensions right? Okay. Just by the way, if you don't want to have to do all this mental math converting between meters and millimeters and whatnot, you could always switch the units of your dimensions by going into our system options, going into document properties, and changing units. So if I were to change it from millimeter gram second into meters kilogram second, for example, and then I have to hit enter because my screen is too low a resolution to see the bottom of the window, the sacrifices I make for you people, I hit the enter sign and everything switches to meters. If I wanted to do that on an individual basis, I could click on one of these dimensions and change what unit it's using on the left as well. I can change a number of things about it. I could have it dimensioned in both meters and inches if I wanted to. I could have a certain level of tolerance appearing. Everything by default is rounded to 2 decimal places. I could have 3 decimal places if I was showing like 1/8 of a meter or something. All of those are within our power. But For now, we have a fully defined sketch. Everything is black. That's a good sign. We can exit the sketch and start sketch number 2. What sketch would you like sketch number 2 to be on? Hold on. Let me try that again. What plane would you like sketch number 2 to be on? Correct. We want it to be on the top plane because we want it to intersect one of our endpoints of our sketch number 1. So on the top plane, I'm going to create a sketch of a circle, and I'm going to position the center of that circle as intersecting with this endpoint of this line here. I can reference the other sketch just the same that I could reference the edges of the contour when we were creating that bracket pin thing back in week number 1 and 2. So because I have the center point coincident with this line, I don't have to worry about trying to position this circle. If I were to change the dimensions of this handle, maybe I want a longer handle, maybe I want a shorter handle, all of that dimensioning would propagate the position of this circle as a result. So the only other thing I have to dimension here is the diameter of this circle. What is the diameter of that circle? Correct, 0.05 meters. Now it's fully defined, good sign. So I have 2 sketches. I have the shape to sweep, and I have the shape to follow when sweeping. So now that I have both sketches created, I can go up into features. I can click the swept boss/base feature. It'll ask me for 2 sketches. The first sketch, the one highlighted in blue here, is the sketch to sweep through space. I can physically click on the shape if I want, or I could go into my hierarchy and actually click sketch number 2. It doesn't matter. And then it's saying, okay, now this one needs to be the shape to follow through space. So I say, gotcha, sketch number 1. It creates a little yellow preview. I can accept it, and I have the handle. I will point out that in this particular case, the cross-section of the sweep that we are creating is a circle. And one of your options when you're creating a swept feature is to assume a circular profile. So we could actually get away in this particular case with only using one sketch. For example, if I only had this sketch existing, I could create a swept feature with a circular profile and then specify the diameter. But, you know, for character building, we should get into the habit of creating 2 sketches. Does that logic make sense? Okay, one example down. Let's try another example. Let's try to make a paperclip. These are the dimensions for a standard paperclip. These dimensions are given in units, and I know that the diameter is going to be just 0.1. So as a result, I only have 1 sketch to have to create. I could approach this by creating a couple of circles, maybe one at the top, maybe one here in the middle, maybe one here at the bottom. I could tell Solidworks that I want both of these end sketches to be positioned around the center of my horizontal sketch. And then this one may have to move left and right to be able to accommodate the fact that it has to be positioned above the origin. Then I could create a couple of lines, starting on this line over here, starting on this line and ending at the bottom, a line that starts over here and goes up, a line that goes down on this side to right about there. Now, I can double check that these relations are what I want by clicking on the line and reading what relations it has. Being parallel with another line that's vertical means that it is also vertical. So I have approximately the shape that I want, which is a good sign. Now I'll go through and trim the pieces of the circles that I don't need. I personally prefer circles as opposed to arcs because you don't have to deal with that whole, is it going to be going on the right side of the arc or not? And I just would much prefer to not play that game. Speaking of games that I'm playing, I seem to have a bit of an issue here on the right side, but I can fix that issue by getting rid of this vertical position. So I had the bottom circle positioned vertical relative to the origin. Now I can make that right line vertical and I don't break any rules of geometry. He said, in the process of breaking rules of geometry. Don't you guys love it when a plan really comes together? I don't know, I don't have any handle joke pun opportunities in this one. What am I going to do, guys? Well, this is just another example of a situation where troubleshooting is really the lesson we're trying to learn. Remember, again, we are going clearly way too fast for anyone to keep up, so that is an important thing to be aware of. Okay, now I can start dimensioning because I have the approximate shape established. I'm going to establish the top diameter as 10 millimeters, the bottom diameter as being 9 millimeters. Half a 9 would be the radius, so 4.5, or 9 divided by 2. That doesn't seem right. Let's try that again. 9.5. Nope. 9 divided by 2. Hey! Great, or shall I say, sweet victory here. Now, radius on that top one of 3.9. I could establish the distance between the top and bottom circles. Maybe 31. The length of that left arc. That's 3. That's not 31. That seems closer. Yeah, that's much more better. Okay. Now, the length of that right line, let's make that 24, shall we? Okay, I have an approximate shape of a paperclip. That went excellently. Let's just take a minute to reflect on the fact that despite the fact that I have a bunch of dimensions established and a bunch of relations of those lines established, everything is still blue. Why is it still blue? Well, remember, blue implies that it's not fully defined. What aspect of this sketch is not fully defined? Right. We cannot have a fully defined sketch until it's positioned relative to the origin. So what do you say? Make the origin in the center circle? See, it works for me. Now I have 2 blue parts left, this top section of the inside part of the paperclip and the bottom part of this left line. Both of those will be constrained if I establish a position of this circle because the length will constrain this bottom point as well. The only dimension left on my sketch is 22 millimeters, which is the distance between this circle and the center of this circle. So I will establish 22 millimeters. My sketch is fully defined. Now I can create a swept base using that circular profile. And when I go in to create a 1 millimeter diameter, you'll notice that it breaks. The reason it breaks is because if I were to create a 1 millimeter diameter circular profile, these are positioned to be 1 millimeter apart. And do you remember what I said about Solidworks not liking it when a sweep intersects itself? So despite the fact that this is actually only the end of the circle that's intersecting the end of the circle, it can't handle it when they touch. So in this case, I would either have to create a slight offset between these two lines. Maybe instead of 1 millimeter, I can make them be 1.0000000000001 millimeters. That would work. Or I could make the diameter of this circular profile a little bit less than 1. SOLIDWORKS only uses about 6 decimal places for precision here, so anything more than that, and we effectively have 0.9 repeating, which is 1. So, a little bit less than 1 millimeter gives us a paperclip. Did you guys come up with any puns? We are really holding it together. I like it. I feel like this would be an excellent opportunity for the Clippy assistant to appear and ask us if we need help. You guys are probably too young for that. Oh, well, whatever the case, that is the sweep feature, and that concludes everything that we're going to talk about with these 3 features. We've talked about the extruded base and extruded cut. We talked about the revolved base, the revolved cut, and the swept base and swept cut. We are done with discussing our features. These 3 features get you about 96, 97% of the way through anything that you need to create in SOLIDWORKS. They are the meat and potatoes of creating material in SOLIDWORKS. The only other one that you might use in very, very specific circumstances would be the lofted base feature. I'm not going to make you use that for any homework assignments in this class, but in case you're curious, the swept base follows a path through space. The lofted base creates a path and profile automatically that connects 2 shapes. So I'm from the thermal fluids field, and we use that a lot in duct geometry. So for example, these diffusers up here in the ceiling, have a circle at the top of the diffuser, but the output of the diffuser needs to interface with the suspended tile system, and so it has to be square. We also use that in intake and exhaust. You may want an intake profile that isn't circular, but you want your duct to be circular to minimize drag within a line. So if I wanted to create a connecting piece between a circular cross-section and a rectangular cross-section, I can create a lofted base. For funsies here, we could create one. However, because I want our two sketches to be in the same field, I want them to be parallel to one another, I can't just use the cardinal planes. So these three planes are great. They are very useful, but in some circumstances, we have to create additional planes. That's a type of reference geometry. When you want to create reference geometry in SolidWorks, you go up to the Features tab, you go over to Reference Geometry, and in this case, we're going to click Plane. We can create a plane in any position we want. In this case, I might want to create a plane that is parallel to the top plane. And in addition to being parallel with the top plane, I could also have it a specific offset away. Maybe I'm creating a part that is 150 millimeters long. In that case, I could specify a distance of 150 millimeters, and now I have established a fully defined plane in space. So I have my three cardinal planes, front, top, and right, and now I have this additional plane called plane 1 that is parallel to the top plane and positioned 150 millimeters above it. Why don't I have to position its left and right or forward to back position? Well, it does position the center of the plane to be centered to the rest of the other planes. In this case, it's going to be centered over the origin, but the plane extends infinitely in the forward to back and left to right positions. So it doesn't actually matter where my plane is. I can still sketch on the plane even if I'm off of this little preview. This little preview is entirely arbitrary. I can click and drag. But now I will create, let's say, a circular cross-section on the top plane. Maybe I want it to be here. And let's say I want that diameter to be 120 millimeters. Maybe I'm interfacing with a 120 millimeter fan. And actually, I'm going to account for some wall thickness. Let's say I wanted the wall thickness to be 2 millimeters. So in this case, I would make this to be 124 millimeters. And we have a fully defined sketch on the top plane. Now I can create a new sketch here on the plane that we created, which we had called plane 1. And I could create a rectangle that started in the center of the top plane, or the origin, and maybe it had a vertical distance of 60 millimeters, accounting for 2 millimeter wall thickness. Let's go with 64. And then let's say we wanted the width to be 204 millimeters. There. That's a nice rectangular section with approximate area that's the same as the circle. Now I have two fully defined closed profiles on two planes. If I get sick of seeing this weird rectangular plane, by the way, you can hide them by right-clicking on the plane and selecting Hide as one of your options. It still exists, we can still reference it, but now we're not seeing it in our little preview window. So just like with the swept base and the swept cut, I can create a feature from these two sketches. Within the loft, these two shapes are called profiles. And just like with the swept feature, I can click on the sketch itself, or I can click on the shape to come up with the profile that I want. So one of my profiles is the circle, the other profile I want is this rectangle, and SolidWorks automatically figures out how to connect both of them. In this case, it's connecting them with as simple a geometry as it can, just a straight line. So from any direction, I have a straight line connecting the corresponding parts of the rectangle and the circle. If I wanted to have a more specialized shape, maybe I wanted the duct to follow a circular arc, I could establish what's called a guide curve with a third sketch, but one thing at a time. So I've now got a loft here between those two sketches. It handled all the math to figure out how to transform one shape to the other automatically. Very convenient. Now, I could create two new sketches if I wanted to create a cut section in the middle that allowed for a 2 millimeter wall thickness, or I could actually go back and reference those two sketches again. Anytime that I want to reference a sketch instead of a feature, I just have to open it under the hierarchy. So I could establish another circle on sketch 1, maybe a circle that had a diameter of 120 millimeters, or I could say is 2 millimeters away from that outer circle. And then I could repeat the same process on the other sketch, but when I try to exit this feature, it's going to give me an error. The reason it gives me an error is because earlier on when I had created the loft, I had just said use sketch 1, and that was all fine and dandy when I only had one object that was closed, one closed profile on the sketch. Now there's more than one closed profile and SolidWorks doesn't know how to handle it. So I right click on this feature, I go to edit feature, he said right clicking on it, and it says error sketch 1. So I can't just use sketch 1, I have to specify which closed profile from sketch 1 I want. So I'm going to right click on the error, I'm going to delete that selection, and I'm going to go in and I'm going to specifically click on the outer circle. When I click on the outer circle, it's going to pop up with a little helpful dialog that allows you to specify, do you want to create a profile out of individual shapes, or do you want me to guess at the closed profile? And guessing at the closed profile is fine here because there's only one shape involved. So I can actually just click the green check mark. If I didn't want to click the green check mark, I could also say, assume a closed loop from this shape, SolidWorks, and it accomplishes the same thing because that's what it does by default. So I click the green check mark and I have selected that outer circle. Hooray. I could also go through the same process with the other sketch while I'm here. So instead of clicking on sketch 2, I'm going to click on this shape. I'm going to say nothing because it doesn't pop up because there's only one closed profile. And I'm going to accept it. Now let's go into this other sketch and establish another rectangle. I'm going to use a center rectangle because nothing is less confusing than a whole bunch of construction lines. I'm going to manually dimension the right and top sides, even though it would make more sense to have them be linked. But time is of the essence. Again, it pops up with an error that says, I don't know which closed profile you want, and that's clearly not the right shape. So I'll right click on the loft. I will say, hey, instead of sketch 2, let's instead use this outer rectangle. So when I click on the outer rectangle, again, it goes, hey, do you want me to try to figure out what shapes create that closed profile, or do you want to do it yourself? And I say, no, you're good. SolidWorks, you did an excellent job of creating a rectangle. I'm very proud of you, SolidWorks. You've lived up to my expectations wonderfully on this particular case. So I have the loft back to where I had it before. I've created 2 new profiles within these 2 existing sketches. So you're probably thinking to yourself, but John, when you create a new profile, what sketches are you going to be selecting? Well, worry not. If I go up to features and I go to swept cut, nope, not what I want, lofted cut, because we're creating a loft. Now under profiles, instead of trying to click the circle on a sketch that doesn't seem to exist, I can open up the hierarchy, right click on the sketches, and just like as the reference plane became hidden when I hit it, the sketches are hidden when you create a feature from them. It assumes that you don't want to see that sketch that you created. It assumes you want to see the feature. So if I right click on this sketch, I can say show, right click on the other sketch and say show, and now I can zoom in and select the inner circle. It says, do you want me to close the loop? I say yep. And then I click on the inner rectangle and it says, do you want me to? And I say yep. And then I accept the cut. Now I'm going to go in and hide those sketches again, because who wants to see those sketches? And look at that. How neat is that, right? So at this point, using those sketches, I could also create a little extension on this duct. Maybe I wanted to be a little further straight before it exits to try to ensure that I have as laminar a flow field as I possibly can. I could create an extrusion on the other side using that other sketch in the same method. Maybe I want this to be 10 millimeters. And in fact, maybe I want to create a mounting flange for the actual mounting of a fan to this. I could use that sketch that we created earlier, or I could go in and create a sketch on this bottom face. And in this case, let's establish a rectangle. Maybe I want this rectangle to be at a distance of 150 millimeters. I can make that square by applying an equal relation. Now I could add some circles. In fact, let's create another rectangle starting from the circle and going out. I'm going to select that rectangle. I'm going to tell SolidWorks I want those to be construction lines. I'm going to add a couple of circles here, which is where you would mount your fan to your duct, probably with some sort of screw and or bolt. I'm going to tell SolidWorks I want all of these to be equally sized. I'm going to add a dimension. In this case, let's go with 5 millimeters. And I'm going to tell SolidWorks I want that spacing to be 120 millimeters. So now I've got another closed sketch. I can extrude over the sketch that I created earlier. And just for fun here, I could actually extrude out to this vertex, and then I don't have to worry about how thick that flange is. If I were to resize the extension, it would automatically resize that extension as well. Now, of course, for this to actually work, there needs to be some air movement through it. So I will go in and add a circle. I will tell Solidworks that I want it to figure out which profile makes the most sense. It does. And there we have a feature. This leads us into the next feature we're going to talk about. We've hit all of the primary features that we're going to talk about in this class. The extruded base, the swept base, the lofted base. That's the first block under the features ribbon for features that create matter. The second block is for features that remove matter. The third block here is for all of the manipulation of existing features. So in this case, the first thing that we have is a fillet option. You'll remember earlier, about 20 minutes ago, when I was trying to create the shape of a handle to extrude, I had used a fillet on a sketch. I also have the ability to create a fillet on three-dimensional features. The logic is the same. It creates a roundover that connects to perpendicular, actually they don't even need to be perpendicular, creates two intersecting fields. In this case, I might, for example, want to create a fillet, maybe on this outside edge. When I create a fillet of features, it's the same process like it was when I create a fillet in the sketch. I specify a radius, and I could turn on preview, which had gotten turned off for some reason. Maybe I want this to be a 10 millimeter fillet. Maybe I want it to be a little bit bigger, 15 millimeters. And create a little bit more material to reinforce the structure of this. Maybe I want the transition between this lofted shape and this linear extruded shape to be softer to try to minimize our losses. I could create a fillet on that edge just the same, and I could even create a fillet on the inside edge as well. If I keep these radii the same, then I don't have to worry about cutting off part of the material, and there we go. So by default, this was 10 millimeters. If I wanted to make it a little bit bigger, I could go with, let's say, 20 millimeters. Oh, that's not quite big enough. Let's go with 50 millimeters. Nay, 100 millimeters. That was fun. Now we've got a rounded transition between the outward extrusion of that diffuser and the linear extrusion of the diffuser. How's that for a neat part? Now we just send this to the manufacturer and let them figure out how to handle this whole nonsense down here. As a general rule, most students tend to over-fillet things. A phrase I like to refer to is fillet the crap out of your field. In this case, it might be tempting to just go crazy here and create a whole bunch of rounded edges. Maybe you just want everything to be round because that's the age we live in. There are no sharp edges on anything anymore. Everything is rounded, and that makes it beautiful. And the problem with that is the manufacturing process becomes way more complex every time that you add a rounded edge to something. So just bear in mind, it's all well and good in this class where you're creating things that no one ever actually has to manufacture. But when you are creating something in reality, adding a fillet to literally every edge that you can add a fillet to just makes the manufacturing process longer, more complicated, and more likely to fail. On the subject of fillets, another option that we have is a chamfer. I call it chamfer because that's what I was taught it was called. If you are watching YouTube videos and or talking to people in real life, that's probably something that you guys don't often do as engineering students, but it happens sometimes. You might hear this referred to as chamfer. You might hear it referred to as chamfer. You might hear it referred to as camfer. You might hear it referred to as camphor. Those are all four pronunciations which appear to be equally valid. I call it chamfer, so we're calling it chamfer. Just heads up. If we wanted to create a chamfer around the edge, that is the same logic as a fillet, except instead of creating a rounded edge, it creates a bevel. So in this case, I could bevel the edges of this shape for some reason if I wanted to, and it's the same process as creating a fillet, except it creates a bevel instead of a rounded edge. If you were actually designing parts, something that you bear in mind when you're creating intersections of parts is something called stress concentration. And chamfer or chamfer is a common way to try to minimize stress concentration. If you chamfer your corners, then you give it more area to disperse that stress, and it doesn't concentrate in one place, which is likely to fail. Questions on fillets and or chamfers? Okay, I will also point out that within this field, you have the ability to create patterns, which we're going to talk about next. You have the ability to create some cool features here. You can automatically add ribbing to an intersecting flange for support if you wanted to. You could add draft, which is kind of like a loft, which allows for overshooting material a little bit. You can add shells, which create a three-dimensional object from a two-dimensional profile. It's much like that thin feature mode of the revolved extrusion did when we were creating that bizarre glass over here 2 weeks ago. The one that might be the most useful to you is the wrap. The wrap feature of these options here creates a projection of a two-dimensional plane onto a curved surface. So for example, let's say that you were trying to let's say you wanted to create a cut on this shape that was some sort of lettering. Maybe you're typing in the name of your business and you're going to have a little bit of a bevel, or maybe you're putting in some sort of instruction about this way is the top, or this way is the down, and air flows in this direction, whatever. You might say this way is up, and maybe an up arrow here. So when you create text on a sketch, you can use the text as closed profiles, and you can manipulate the features in the same way that you could with any other closed profile. So for example, I could cut all the way through my feature now and create a nice little cutout for this way is up and QC is... In this case, it doesn't make a whole lot of sense for us to do this all the way through the material because we end up with floating bodies. That's what Solidworks is warning me about. It said, hey, just FYI, you have now created multiple separate three-dimensional pieces. And I said, yeah, it's fine. It's an example, Solidworks. I don't need it to be manufacturable. So in this particular case, creating a cut with that sketch was easy because we drew a sketch on a flat surface, and what we were cutting out is a flat surface. But if you were trying to create the same, I don't know, let's say you wanted to create a koozie out of plastic for your Monster energy drinks, and you created a plastic shell that was 5 millimeters thick that went all the way around your can, and then you wanted to create a little bit of an extrusion on that said, I don't know, this Monster energy drink is the drinker's and no one else's, and anyone who touches it will fear the wrath of the Monster energy drink drinker, or something to that effect. In that case, you wouldn't be able to create a sketch on that rounded edge because you can only create sketches on two-dimensional surfaces. So what you would have to do is create a reference plane that was tangent to this curved surface, and then you would have to create the sketch on that reference plane, and then you would click this wrap button, which would project that plane around a curved surface. And then you could create the extrusion or the cut as you see fit. Of course, there are more useful ways. More useful things to do with a wrap. For example, if you wanted to create knurling, knurling is most easily done with a wrap. You could create something that had a little bit of a texture to it to make it easier to grab and less likely for you to drop it when you were drinking your Monster energy drinks at, I don't know, a football game or whatever it is you people do these days. That's the idea of a wrap. Everything else is the same in a two-dimensional sketch as it is in a three-dimensional feature. Questions on what we've done so far? Okay. So what I want to talk about next is the difference between patterns on two-dimensional shapes and patterns on three-dimensional shapes. You have the ability to create a pattern on a two-dimensional sketch out of sketch entities. So let's say, for example, that we wanted to create a cutout on this rectangle. So let's say I had a rectangle, it was 10 millimeters thick, and on this rectangle, I want to create a cutout that is a whole bunch of small squares. Maybe something like this, something that is approximately 15 millimeters across, and I want a whole bunch of them, as many as I can possibly fit on this feature. I could create a whole bunch of squares, but I don't want to do that. That would be too much time invested for the pay that my company is giving me. It's also less likely that I'm going to do it accurately because SolidWorks is less likely to screw up in that process of creating a whole bunch of squares. It also is very labor intensive for the computer because it has to keep track of a whole bunch of features that are independent of one another. In this case, if I wanted a whole bunch of squares like this, I could create a linear sketch pattern. I will remind you again that sketch patterns are different from patterns of features, which we'll talk about next. But linear sketch pattern is going to create a pattern within the sketch of some sketch entities. So when I go up to linear pattern, if I scroll on down and I select entities to pattern, and then I select the entities that make up the shape that I want to actually pattern. In this case, I don't have a helpful pop-up that says, hey, do you want me to try to close that sketch for you? No, I have to click on the edges of the rectangle individually. And then let's say I wanted the spacing to be 20 millimeters, and I want not 2, not 3, not 4, but 13 of these things. I could click OK, and I have a pattern. The problem with creating these as features is that once you've created the cut and you've patterned the cut, that's just done. It is complete. Your feature and your pattern of features are only relative to one another. The advantage of a pattern within a sketch is that you can manipulate the sketch just like you would if you had created them all by hand. So let's say in this case, I wanted the spacing between the squares to be equal, and I wanted there to be whatever spacing was required to leave it so that the distance on the left and right side of these cutouts was the same as every other spacing. I don't want to have to do math and figure that out. I also want it to scale if I were to change the shape of this rectangle, or maybe change the dimension of that square. So I can go in and create a construction line over here on the left and create a construction line over here on the right, let's say. And I can tell SolidWorks that I want those two construction lines to be equal. And SolidWorks will manipulate all of these sketch entities to accommodate holding those equal. And because this is created from a pattern, it scales the offset between the pattern entities to be whatever it needs to be for them all to be the same. Does that logic make sense? So if I were to, let's say this cutout goes 5 millimeters from the top and is positioned there all the time, I will point out that I still have some blue on my sketch, which implies that some aspect of this is not fully defined. So I will say one more construction line, and I will tell SolidWorks that the spacing between the squares and the spacing between the squares and the edge is the same. Now everything becomes fully defined, which is what I want. So because I created this as a sketch pattern, if I were to change the dimensions of that original rectangle, maybe making this, say, 350 millimeters across instead of 275, the squares are still equally spaced. Or maybe instead of 350, let's go with 500. If I go back into this sketch, the squares are still equally spaced. It was able to manipulate the sketch entities to be able to accommodate what I actually wanted. Now, if I were to, let's say, create a cut from these squares, maybe that's what I wanted to do all along. I created a cut from those squares out of a sketch, a single sketch. Now, contrast this to if I had created a single square and created a cut from that. So maybe a single square, that's not quite square. That's just the theme of the day, isn't it? And if I were to create a cut through the rectangle with this square, I have created a feature. I can create a pattern of features, just like how I created a pattern of sketch entities. I go up to linear pattern and I select the feature instead of the individual instance. So under features and faces, I select the feature of the cut. And now I can go up here and say, I want this to be, let's say a 25 millimeter spacing, and I want there to be 13 of them. 25 millimeters doesn't seem right. Let's go with 35. Oh, that doesn't seem right. Maybe 40. Oh, that doesn't seem right. Maybe 37. I don't have a convenient way of referencing the length of the rectangle because the feature already exists. I can't go into SolidWorks and say, okay, I created all the cuts. Now can you position them? Oh, no, I can't anymore because the feature is existing in space. I cannot reference the existing entity like I can with a sketch entity. However, the advantage of doing a feature pattern like this is that I could have, let's say instead of just a square cutout, maybe I wanted a square cutout that had a whole bunch of chamfers around the edges, because you guys know how much we love to apply chamfers and fillets to things. Oh, maybe the chamfer itself isn't quite enough. Maybe I want there to be, oh yeah, let's make a rounded edge on the inside. I think that looks better. And oh man, maybe a round over on the top edge too, because that's not quite right. And then, oh man, everything's round. I like that, but this corner needs to be round too. That's not quite round enough. And let's make that be, I don't know, 5 millimeters instead. So we've applied a whole bunch of features to this one cutout. If I wanted to create a pattern of sketches in the same way that I had done before, I could only create one feature from that sketch, and I would have to go in and manually apply all these fillets and chamfers. But now that I've got them existing on the one thing I want to pattern, I can create a linear pattern like I did before. I can say I want you to pattern off to the right, 38 millimeter spacing, and then instead of just clicking the square under features to pattern, I can click the cutout for the square, and I can click all of the everything else. Like for example, the chamfer, I can click all the features in the form of fillets, and there I have a pattern of all of that crap that I had applied to the square. So the advantage of creating a sketch pattern is that you can reference other things within the sketch. The advantage of the feature pattern is that you can pattern a whole bunch of features at once. We will pick this up next week. I will point out that your homework assignment this week is a cup or a mug. It is a rocket, and it is a bishop. You may recognize these because these 3 parts are the 3 parts that I've created tutorials for on the YouTube channel. So if you want to, there is a video corresponding to every problem on the homework this week. So if you are having trouble with it, there is a video there to tell you how to do it. The goal of this week is to make you better at using these features. Does that make sense? So be aware that's available to you. Think of it like the Chegg of your SolidWorks homework.